Hey guys, so everyone knows that we need oxygen to survive. And if we don't get enough oxygen, that we will die. But for some reason, a lot of people are not getting enough oxygen. Yeah, they're getting enough to survive, but they're still not getting enough. And this can lead to a lot of different diseases, like pretty much your entire body will get affected. It can affect the functioning of your brain, and it can make you stressed out, it can make you chronically tired, so it can cause a lot of issues. So what could be causing this lack of oxygen? So just to be clear, I'm not talking about a lack of oxygen going into your lungs. I'm talking about a lack of oxygen that's going into your cells in your body. So what's the difference here? So let's backtrack a little bit. How much do people normally breathe in the first place? So most people are actually breathing about 12 to 20 breaths a minute. So that'll equate to about 30,000 breaths in a single day. And in a year, if you want to get fancy, that'll be about 10 million breaths in a year. So you might be looking at these numbers and thinking, what's the big deal? This is probably normal. Well, the answer is actually no, this is not normal, but I'm going to get to that in a second here. But what you should take away from these numbers is we are getting plenty of oxygen into our lungs when we breathe this much. So this is just kind of reiterating the issue. The issue is not getting oxygen into our lungs, it's once the oxygen enters our lungs, where is it going and how do we get it to go into the right places? And a lot of people might think that, oh, I just need to start breathing more because if I get more oxygen, then I'll get more oxygen that'll eventually go to my cells. But this is part of the problem. And the issue is the way that we're breathing in the first place. A lot of people are not breathing the way that they're supposed to. And you might be looking at me like I'm crazy, like, obviously I know how to breathe. Air is going into my lungs and air is coming out of my lungs. Well, the way that I'll respond to that is just because the way that you're breathing is keeping you alive, it still doesn't mean that you're breathing correctly. For example, I could be eating cheeseburgers every single day for the rest of my life. Wow, that actually sounds pretty nice. Cheeseburgers are food, and food is going into my body and food is keeping me alive. That doesn't mean that those cheeseburgers are good for you, and that doesn't mean that I'm gonna be healthy. And remember when I said that when you look at these numbers that this breathing is not normal? Well, people did not always breathe like this. Let's go back in time a little bit. So about 100 years ago, or in the 1920s, people would breathe about 6 liters of air per minute. Then if you look at this graph here, during the war years, this rate of breathing dropped a little bit because there was less food, there was less protein, there was less resources, and then you'll notice a difference in the 1950s. The 1950s is when McDonald's and KFC hit the market, and this is when breathing rates shot way up. That's really weird. People started eating fast food, which is really unhealthy, and then it changed the way that they breathe. And if you look at the right of the graph, now the breathing rates are at about 12 liters per minute, and if you really update this, it's probably even higher than that. Now I'm gonna pause right here for a second. There is no way that people should be breathing double the amount that they used to 100 years ago. Something is clearly wrong here. And when you combine these higher breathing rates with people breathing incorrectly in the first place, it's gonna cause a lot of harm to our body. It's gonna cause a lot of stress, and it's gonna cause a lot of chemical imbalances. Now I don't want you to focus too much on your breathing rate, because that really could change person to person. For example, a lot of people would be fine breathing about 6 breaths per minute, but some people would be fine breathing 4 breaths a minute, and other people would be fine breathing 9 or 10 breaths a minute. So don't focus too much on the frequency that you're breathing. I'd rather have you focus on breathing correctly in the first place, and everything else will kind of fall in place after that. So I want to direct your attention to my beautiful diagram here. If you didn't know, these are your lungs. So remember when I said the issue is not getting oxygen into your lungs? Well, the reason is because our air has about 21% oxygen in it, and our lungs really only need 5%. So that means at any given time in our air, we have 4 times the amount of oxygen in the air around us. And if you want further proof, when we breathe out, 16% of that air is still oxygen. So how can we start using this oxygen better and start increasing the amount of oxygen that goes in the cells in our body? Well, the trick is to increase a different chemical called CO2, or carbon dioxide. So a lot of people give this carbon dioxide a bad rep. They call it a toxic waste that we need to get rid of, and we need to expel it as much as possible. But that is simply not true. Carbon dioxide is very important. It's actually just as important as oxygen. For example, this carbon dioxide is what controls the pH, or how acidic our blood is, or how basic our blood is. And also this CO2 is going to be what helps deliver our oxygen to all of our cells. And if you remember from chemistry class or biology class or wherever you learned this is called the Bohr effect. Basically what this Bohr effect is saying is that when carbon dioxide levels are high, that more oxygen is going to be released from a molecule called hemoglobin into our cells. And when carbon dioxide is low, this oxygen will not be released from this hemoglobin, and even though it gets into our lungs, it will never go to our cells. So how do we get carbon dioxide? Well, we definitely don't get it from breathing, because in our air around us, we only have about 0.03% carbon dioxide. But luckily, our body can produce this carbon dioxide on its own, and it does that in two different ways. One is by exercising, and two is just our metabolism, so just existing. So for example, if you hold your breath right now, the metabolism is still going on in your body, so your body's going to produce more and more carbon dioxide. But every time we breathe out, we're releasing this carbon dioxide. So again, the two ways we get carbon dioxide is by exercising or our body's metabolism, which goes on all the time. So the job of our lungs is to constantly exchange this oxygen and this carbon dioxide. That's really all the lungs are doing. And if we want our body to function really well, and we want all of our cells to have oxygen, and we want our brain to have oxygen, then we need our carbon dioxide levels in our body to be at about 6.5%. And the way that carbon dioxide is measured is in terms of pressure, so that would equate to about 40 millimeters of mercury. So we need about 40 millimeters of mercury in our body for our CO2 levels to be good and for our body to function normally. So if you look at my other beautiful diagram, this is the brain and this is the brainstem. So this brainstem is what triggers us to take a breath. And it has that trigger when it detects our carbon dioxide levels. So typically, when our brainstem sees that our carbon dioxide builds up to this level here, this magic number, this 40 millimeters of mercury, it's going to trigger us to take a breath. But the problem is, like I showed you before, people are not breathing correctly anymore. And as a result, our breathing rate has gone up so much. And in doing so, this normal number of 40 for our carbon dioxide has actually gone down. Now what happens is, over time, when our carbon dioxide levels stay down for so long, our brainstem trigger starts to get lower. So now, for example, instead of being 40 millimeters of mercury, our brainstem trigger is going to be at 35. And it could go even lower, it could be at 30. And this is what happens. Now, when we have lower levels of carbon dioxide in our body, our brainstem is going to be triggering these breaths faster and faster. So basically, it's going to be a never-ending cycle because we're going to keep breathing faster and faster. As a result, we are taking a breath, but if you look at biochemically what our body was designed to do, we're taking a breath too early. So how can we start increasing our carbon dioxide levels to get up to this magic number again? And how can we start breathing normally again so that we maintain this number? So the trick to functional breathing is going to be these four things right here. So the main two things I want you to focus on are the first two. It's going to be using your nose to breathe and using your diaphragm. Human beings were meant to breathe through their nose. They were not meant to breathe through their mouth. And this is actually one of the main reasons that people's breathing rates have shot up. Because when you use your mouth to breathe, it's going to lead to quicker and quicker breaths. And the reason is actually pretty simple, because your mouth hole is super big, and when you breathe through your mouth, you're really going to only be filling up the upper half of your chest with air. So you're taking these quicker breaths that are not filling up your lungs all the way, and this is what's going to lead to that rapid breathing. Whereas opposed to your nose, you have these smaller nostrils. So when you breathe correctly through your nose, this is going to help regulate our carbon dioxide levels. And the reason is simple. We're breathing slower now. So when we breathe in, we're breathing slower, and also when we exhale, our air is coming out slower. That little bit of time difference is going to help make sure that we produce more carbon dioxide in our body. But also you want to be using your diaphragm. So how do you use your diaphragm when you're breathing? Well, this is also pretty simple. So when you inhale, take a big inhale and feel your belly. If your belly is sticking out, that means that you're using your diaphragm. If you just see that your chest is rising, but your belly is the same, then you're not breathing correctly. You want to make sure you're filling up your lungs' whole capacity. And the way to do that is to engage your diaphragm, which rests right under your lungs. And to ensure that you're doing that, you gotta make sure your belly's sticking out when you're breathing. Now, the other two keys to functional breathing is you wanna make sure you're a silent breather. So this one's gonna be a little harder because let's say you are breathing through your nose and you hear a whistle or something is going on where you're having some sort of obstruction. Anytime you hear a noise when you're breathing, it means that there is some sort of obstruction in your airway. For example, a really easy one to pick out is snoring. A lot of times we think snoring is just a nuisance. It's so annoying. Well, yes, it is annoying, but also it's a real problem because it means that someone has some sort of obstruction in their airway and they're not breathing correctly. And the last point I had here about functional breathing is you don't need to focus as much on this because if you do these first two things, really, this is gonna happen. So on average, functional breathing is gonna be about 8 to 10 breaths a minute or 5 to 6 liters of air per minute. And I also have a study that further shows how important carbon dioxide is for our body. So this study involved 3 different groups. And in all of these groups, they induced hypoxia, or lower levels of oxygen. So one of these groups was the control, where they just lowered the amount of oxygen, and after 5 minutes, they had to recover on their own. Then the other 2 groups had these hypoxia air conditions, but they were also supplemented with carbon dioxide. So the second group had a mixture of 3% carbon dioxide in it, and the third group had a mixture of 5% carbon dioxide in it. So what they did was they exposed these groups to lower levels of oxygen for 5 minutes, and 2 of those groups they were studying had carbon dioxide mixed in that air as well. And just to clarify, before the study began, there was no real difference in people's oxygen levels. So what they found was during the exposure, the group that was purely hypoxia, so they had no carbon dioxide in it, they had the quickest drop in their oxygen saturation. And what you'll notice is the groups that had the carbon dioxide kind of acted like a buffer. So their oxygen saturation did not drop down as fast. If you look at the 3% CO2 group, theirs dropped down slightly, but the 5% group hardly dropped down at all. And also if you look at the recovery period, the groups that had carbon dioxide in it recovered very quickly. Now looking at the graph, you'll see that the 5% group recovered the quickest and their oxygen saturation stayed the highest the whole time. And for both of the groups that had CO2, they only took 2 minutes to return to their baseline levels of oxygen. And actually, they even ended up exceeding their baseline levels of oxygen. But on the other hand, the control group did not exceed their baseline and they took a whole 5 minutes to get back to their baseline. So that just further shows the importance of carbon dioxide and how if we increase our carbon dioxide, it's actually going to increase our oxygen saturation too. Thank you guys for watching. I hope you liked that video and I hope you learned something more about functional breathing and how important breathing is and how we can start breathing correctly. So if you want to learn more about nose breathing and how to breathe through your nose better, I'm putting some links in the description below where I talk more about that. So make sure you check those out. And as always, if you haven't already, make sure you hit the thumbs up button and subscribe to my channel below. I will see you in the next video.